So I think I should confess to an audience of PHP developers. I don't know any PHP. I once tried to hack a WordPress template, if that counts. It was pretty terrible. I hope you never see that code. I've spent a lot of my career writing desktop applications, well, especially over the last few years. And I work at GitHub, and I'm on the team that builds GitHub Desktop, which we just released. And it's a native application that works on Windows and Mac. And it's written in Objective-C and C#. And I really enjoy making desktop apps with them. But there's a new kid on the block, and honestly, I'm really excited about the possibilities. So today I want to share with you how you can get started building desktop applications with web technologies using Electron. So last year, we released a text editor called Atom. Can I get a show of hands? Does people use Atom? I saw Atom being used by one of the speakers today, which I thought was pretty cool. So the idea behind Atom is that it would have like a completely hackable core. So it would be an app that you could download and then start customizing for your own kind of workflows right away. So any developer would be able to write an extension for it. And it's a cross-platform application, and it runs on Mac, Windows, and Linux. And it's built with web technology. So it's written in JavaScript, HTML, and CSS. And all of its extensions and packages are also written in JavaScript. And because it's built with Atom, because it's built with web technology, hacking the editor is really, really easy. And that's because what we're really dealing with under the hood is a web browser. So we get for free all of the cool tooling that we have when we're building web applications. So how exactly does all of this work, and how can we apply our knowledge of HTML, CSS, and JavaScript to build cross-platform desktop applications? So the science behind the Atom text editor is a little project called Electron, and it was formerly known as Atom Shell. Who's heard of Electron? A few less people. Okay, so that's great, because I'm going to be telling you all about Electron today. So if we were to crack open an Electron app, like Atom, for example, and take a little look behind the curtain, we'd see that it combines Node with the open source web browser project that makes up a lot of the code of Google Chrome, the Chromium project. And so if anyone's tried building Chromium from scratch or for each of the different platforms, you'd know that it's pretty complicated. It's not an easy task. So instead of including the entire build of Chromium, what Electron does is it only contains the stuff that Electron actually needs. It uses a part of Chromium called the Chromium content module. And this module contains all of the code that you need to render a web page. So it includes all of the web platform features like HTML5 and GPU acceleration, and then it pulls in all of the dependencies like WebKit and V8, for example. So it combines that together with Node.js to form what is essentially a new runtime, the Electron Runtime. So Node has supported Mac, Windows, and Linux for a very long time now, and Chromium is also cross-platform. So what this means is when you're interacting with this Electron Runtime, you're automatically, for free, getting a cross-platform application. So suddenly we can do a whole bunch of things that normal web browsers can't do. So before I dance around this topic too much, I thought it would be good to kind of just dive in and see how an Electron app fits together. So to do this, we're going to start building a sample application, and our app is going to be called Science. So before we get going, we're going to need to globally install an npm package called Electron pre-built. And so this package is the latest version of this package will make sure that it downloads the latest version of the Electron pre-built binaries for whatever platform you specify, so Mac, Windows, or Linux, and also for whichever architecture you specify, 32-bit or 64, which means that you don't have to do any of those funky builds on each of the different platforms. This is all sort of done for you and ready to go. And this package is also going to add Electron to our path so that we can quickly test the Electron apps that we're building. So when we run Electron now, what we get is an empty Electron app. So this is basically the shell. So we're seeing here our custom Chromium build combined with Node.js. It's ready for us to drag in our HTML and CSS. So we're going to get started to see how we can do that. So the first things first is we're going to initialize our package JSON file. We're going to give it a name and a description. And the next thing we need to do is say what our point of entry is going to be for our Electron application. So this is the JavaScript file that's going to kick everything off. So we're going to specify a file called main.js, which doesn't exist yet. We're going to create it very soon. So this all looks good for now. So we're going to clear that out. And the very next thing that we need to do is add in Electron pre-build as a dev dependency. So we're going to run npm install with --save dev. And now we're ready to spin up our project in Atom. So this is a bit weird, like Inception. We've got a text editor built with Electron, opening a project for another Electron apps. It's a bit weird. So we've got our almost empty Electron app. We've got one module installed, Electron pre-built, and we're going to use this dev dependency a bit later. And we can see that we've specified in our package JSON file our main.js file that we need to execute. And it doesn't exist yet, so we're going to go ahead and create it. I'm going to leave it blank for a short minute or two. So we'll create that. And we're just going to check in via GitHub Desktop all of our files that we have, making sure that we're correctly ignoring the node modules folder. So now we're ready to think about what we need to put inside our main.js file. Now, the thing to know about Electron apps is that they have two kinds of processes. We've got a main process and then a render process. So when we first start our Electron application, we pass it our main.js file, and Electron itself is going to take that, spin up the runtime, and then run the main.js file inside the main process loop. So the main process can be sort of thought of like a master of puppets. So it's going to kick off that runtime, it's going to give your main script access to all of the Electron APIs, and then it gives you a place to coordinate all of the modules that you provide and the sub-processes that you're about to kick off. So just starting that main process doesn't actually result in any user interface, so you have to do that yourself. So inside the main process, Electron has given us access to a module called browser window. And when we start a new browser window, we're going to start by kicking off a new render process. So the browser window is actually that second kind of process, that render process. And that render process is able to take an HTML file that will go away and reference CSS and JavaScript and images and whatever an HTML file does, and it will render that to the window. And since Electron uses that content Chromium module for rendering the web pages, this means that we get Chromium's multi-process architecture for free, completely. So this means that each browser window is running inside its own render process. And this is an interesting thing to keep in mind because you don't always have to open a browser window to make use of this. You can kind of make use of this architecture as almost like a makeshift thread pool, which some of the applications that are out there now built with Electron are actually doing this. It's really interesting. So they spin up render processes in the background and offload really complex tasks to those render processes and keeps those main loops free to be responsive to a user's input. So this is something to keep in mind, a special way of using render processes. So now that we can spin up many render processes and we can render content to it or spin them up to just offload some work, we need a way to communicate into process. And Electron provides this to us via the IPC module. So you just require in this module, you can see I'm requiring it in here inside the render process, and then you can send synchronous or asynchronous messages back to the main process. So inside the main process, you're able to require in the IPC module and then wire up an event and a thing to do when you receive that message. And the reverse also works. There's also modules out there that support duplex communication across the IPC channels. So we're going to spin up a main process to manage many render processes, and we're going to communicate amongst all of those via IPC, which sounds pretty great, pretty interesting. But if I had to pick one thing that was the killer feature of the Electron runtime, it would be that you can require in native modules inside that render process, inside a browser context. So in normal browsers, web pages usually run in like a sandboxed environment, which means that you don't have access to any of the native resources. You can't just hit up the hard drive, for example. You couldn't just bring in the JavaScript implementation of fly system. That would not work. Electron is going to give you access to requiring those native modules, allowing you to do some really funky low-level operating system interactions inside that browser context. So you could require in C++ modules. So here I'm requiring in level DB. Then I am opening the database from the file system, and then in exactly the same breath, grabbing some data out of it and rendering it to the DOM. So you could never do that in a browser. That just wouldn't work. So that's pretty crazy, I feel. You can't do that on a web page. So this is where the power is. So knowing what we know now about how the main process works and the render process works, we can start to fill in the gaps of our main.js file. So we're going to flip back to our example. We're going to start by including an Electron-provided module called app. Now, this app module is responsible for controlling the application's lifecycle. So it gives us hooks into lifecycle events like when the app is starting up, when windows are opening, when windows are closing, when the application is actually ready to start doing stuff, drawing stuff to the screen, and when it's about to quit. So the next thing we need to do is require in that browser window module I mentioned earlier so that we can create browser windows inside Electron once it's ready. An Electron is going to signal to us that it's ready by this event here, ready. So on ready, we're going to provide a function that creates a new browser window, gives it a height and a width, and that's it. So one thing that we do need to be aware of is that we've got to take into account garbage collection. So if we don't keep a top-level reference to the main window, we can find that the garbage collector will run and we no longer have a reference to main window. So we're thinking about the lifetime here by pulling that out and making it survive longer than that one function. So now let's run up the app by giving Electron our main.js file, and we can see that we have a native application up and running. It's got an icon in the dock, but it doesn't do anything yet. It's just blank. So it's just an empty render process, just an empty browser window. So we better give it something to render. So I've dropped in some HTML and CSS. It's not really important what's going on in there just at the moment. It's basically just a template from the Bootstrap website. So we're going to tell our main window that it can now load a URL. And it's going to load a URL, it's going to load a file from disk. It's going to load the index.html file. And so now when we start Electron in our directory, we get an application that renders some content to the screen. And we see in the terminal behind us that we've got render process started, so we can see that that background process is ticking away rendering. We also see that it behaves just like a regular web browser, right? We've got media queries here running, which gives us a way to do a design for a full screen app, for example. So now we have like one or maybe even many render processes, we can start building out our application features. So from within that render process, we can start writing all sorts of JavaScript, calling into native APIs, querying databases. We can do lots of crazy things that we could never do in a regular browser context. Like we can create tray items to give our application a really, truly native feel. And the beauty about the Electron API, the tray API, is that they take away all of the complexities of knowing how to create a tray item on Linux, how to create a tray item on Windows, and it just does it for you. You interact with a tray, you supply it some HTML, and bang, you've got a tray item on each of the operating systems. You can also use the APIs to add in recent document lists, although this is only supported on Windows and Mac right now. And you can also create application menus, which is what we're going to go ahead and do right now. So we're going to create a new file, application menu, and we're going to start by defining the application menu module. We're going to declare the function and then export that as that object as a module. I'm also going to add a setup function to the prototype. So we can require in the menu module now, which is provided to us by Electron, which is going to give us a helper function, build from template, which allows us to build out an array of menu items, which roughly correlate to what we see up here, so our file, edit, view, those kinds of things. So we're going to go ahead and do that. We're going to give our first menu item the label science, and it's going to have a submenu. It's going to contain options for preferences and an option to quit. So we also need to assign this menu to our applications. We need to say this is the application's main menu. So we're going to require in the app module and then set that menu on the application. And to tie it all together, we're going to flip back to the main.js file, pull in our module that we've just created, our application menu module, and then when the application's ready, we're going to set up the application menu. So let's see it in action. So we have one menu item with two submenus, preferences and quit, but they don't do anything right now. So as a quick example of how we can make our menus do things, there's a click function that you can wire up. So here we're just going to wire up the quit menu to actually call application quit. So now when we run up the application, we get the never-ending story. Is it going to start again? Yeah. So we're just going to wire it up for the second time because that's how it goes. We're going to start up Electron in the current directory. Bam, our render process started. We hit quit, and the application quits. So it's really easy to wire up those application menus. So the never-ending story. This is why I'm really excited. Like, it's a sweet runtime. It has a set of APIs for creating a cross-platform, really native experience, and you can do all of that with JavaScript. But what use is all of that without getting your applications out into the world? I mean, it's pretty great when people actually use the software that we write, most of the time. I mean, nobody really wanted to use that WordPress thing that I hacked, let's be honest. It was probably for the best. But most times we want people to actually use the code that we write. So there's a handy NPM package that you can use to sort of package this all up and create an operating system executable that you can then invoke on whichever operating system you're on. So we're going to create science.app. And the way we're going to do that is by starting this NPM package called Electron Packager. We're going to save it as a dev dependency. You can also install this globally and have that added to your path so you can use the CLI to do this as well. And then we're going to invoke the package manager against the packager, against the directory. So we're going to give it the directory we want to package up. We're going to give our app a name. We're then going to specify the platform that we want to build for, and in this case we're building for Mac, for OS X. We're also going to specify the architecture, and in this case we're going to build a 64-bit version of the Science app. And then last but not least, we have to specify which version of Electron we want to build with. So we're going to build with the latest version of Electron. And so what this is going to do now, it's going to go away and download the pre-built binaries using Electron pre-built for that particular platform, architecture, and version of Electron. And now it's created a new app. So if we just have a look at what's in our directory, we've got science.app, and we can actually open science.app, and there it is. So our app can actually now be copied to somebody's machine. It can run in the dock. You can have it sitting in the dock there after you've quit it, and it will remain there just like a regular app, just like any other native application. But really, what we want is cross-platform builds, right? We want builds for Mac, Windows, and Linux. But luckily, the Electron Packager can do all of this for us. So we can just specify that we want to build the current directory with the application name Science, platform all, we want them all. We also want all of the architectures, because we're greedy, and our Electron version. So now this is going to go away and it's going to download each of those permutations of architectures and platforms and the version that we've specified for Electron, and it's going to package our app Science up with those pre-built binaries. So now we can open up Finder and we can see that we've got a science.app. We've got a Linux build, which looks completely different to the Mac build. We've got a Windows build also, which again looks completely different. It's got all the DLLs that you need, and it even has a science.exe. So we can take that Windows build and we can copy it over to a Windows machine. And we can actually use the same code. We can just specify that we want to build the current directory with the application name Science, platform all, we want them all. We also want all of the architectures, because we're greedy, and our Electron This is my life, by the way, VMs, inside VMs, inside VMs. Oh. And so once we've copied that over, we've got science.exe with the icon set, beautiful. We can run it up, and bam, science. We've got application menus that have been implemented. Everything is exactly the same. It just has a native Windows feel. It does exactly the same stuff. It responds to media queries in the same way that, and you can quit. So we did all of that with just a few lines of JavaScript. Pretty much. I was pretty excited about this. So there's a ton of really great packages on NPM at the moment to help you build Electron applications, like Electron Pre-Built and the Electron Packager. But to make the process of building and packaging your applications really easy, there's quite a lot of legwork that you have to do to get going, like setting up your build scripts, setting up your test scripts, how you debug the applications. There's probably a couple of days worth of work in getting that all up and running. So to save you some time, I've created an NPM package to help you do this. So you can install the Electron Accelerator as a global module, and you can use this to quickly initialize your Electron project directory with a set of sensible defaults. And I've got some really cool things that are coming in the next couple of weeks, which I'll tell you about in a moment. But first, let's just install the Electron Accelerator globally. And then we can create a new project directory with science too. We're going to change directory into it, and we're going to run the Electron Accelerator. It's going to ask us what our name is, who the author of the application is, what the application name is going to be, ask you to provide a brief description, things like where does this app live, what's the repository name. Platforms, architectures. Now, this is something that I'm going to talk about very soon, but for the moment, we don't want to support Windows releases. We're going to say, yes, that looks all very good, and it's going to go away and create a template for us. We can see that we have some things being copied into our directory. So this creates a template on disk. It creates a README file that tells you how to run the application, how to bootstrap the application, how to get started running Electron. It creates your package.json file. It also creates a set of scripts that you can use. So you can push this up to GitHub, somebody can download it, they can run script bootstrap and immediately have an Electron app ready to go. They can run script server and immediately have an Electron app up and running on their screen. Build, and coming soon will be package release and just package and release are the last two things. And a main.js file that's ready for you to go. So let's execute script bootstrap. So this is going to go away and have a look at the packages JSON file and download all of the dependencies, and it's also going to add a few things to your path that you need in order to run an Electron app. Takes a little while because it's actually installing Node Inspector. Who's used Node Inspector before? Oh, you guys are really lucky. It's like the only option for, the only real option for debugging processes that aren't running in a render process. So that main.js file that we saw, it's running in its own process loop, and then you've got the render process, which you can spin up, and you can actually open the WebKit dev tools, and it's really easy to debug those processes. But debugging inside the main process, anything that's executing inside that main.js or stemmed from that, is extremely difficult. And so I've, as part of this template, included a way to spin up a Node Inspector context so that you can debug those processes as well. So now we can build our application for the platforms that we specified at the beginning. So we can just say script build. It's going to go away and build your application, package it up for the architectures and platforms that you specified. And we can run our application to test while we're developing by just saying script server. And there we go, that's it. So one NPM package and you are ready to go with building Electron applications. So one thing that I haven't talked about, I mentioned it briefly, was the auto-updating. Now, so Electron has built in a way to support auto-updating your application. So this means that when you publish a new version of your Electron app, it will automatically be checking for updates, and it will, in the background, download that update, apply it, and so the next time somebody starts up your app, they'll automatically have the latest version of your native application. But it's only been implemented for OS X inside Electron so far. And there's an external package to implement this for Windows, and both of those use a technology called Squirrel. Has anyone heard of those? No, so they're relatively new. What about Sparkle? Sparkle's a Mac auto-updating. So Squirrel for OS X is a replacement for Sparkle, and Squirrel for Windows is basically the clone of that on the Windows operating system. So in the next couple of weeks, right now I have inside the Electron Accelerator template, I have a really crude auto-updating mechanism for Squirrel for Windows. That's going to be improved in the next few days. And then in the next couple of weeks, there will also be automatic updates for OS X as well. So this is going to be a really quick way for you to get up and running, building native applications with auto updates ready to go. So that was Electron. It's a cross-platform way to build desktop apps using web technology. It's the science behind Atom, and a growing number of really popular apps like Slack, for example, that's written in Electron. And Visual Studio Code, which is a new cross-platform IDE that just came out, is also written in Electron. And a whole bunch of others as well. So thank you very much for listening. I'm Amit pretty much everywhere on the internet, and you're awesome.